In this video, we're going to look at discrete probability distributions. In discrete probability distributions, you have a random variable. And that random variable is a single numerical value determined by chance for each outcome of a procedure. It's basically your output of what you get. Maybe you're rolling a die and you get 1, 2, 3, 4, 5, or 6, or it's how many TVs in the American household, or something like that. But your random variable, we're going to call X for the most part. And then we're going to assign a probability distribution for each outcome from the random variable. And then we create the probability distribution. Now it's going to look something like this. You have X, and then you have P of X here. And you create a T-chart, something like this. And let's look at a one die roll. In your random variable, you can have 1, 2, 3, 4, 5, or 6. And these are the outcomes that you have from rolling a die. Now here we're going to list their corresponding probabilities. 1/6, 1/6, 1/6, 1/6, 1/6, and 1/6. So here you go. You have a discrete probability distribution. You have your random variables here and your corresponding probabilities here. Now, the sum total of all of these probabilities we know has to be equal to 1. No more, no less. And also, all of these probabilities that are here have to be between 0 and 1. Remember that a 0 probability means that it never happens, and a probability of 1 means that it always happens. Okay? So, now, let's look at a coin toss. In a coin toss, you have heads or tails. The deal is that with a discrete probability distribution, you can't put H or T here because they are not numerical values. X has to be numerical. So therefore, we can get around this by saying, okay, let's make this the number of heads. And we can have 0 head or 1 head. So this means that we're getting a tail here, and here we're getting a head. So there are ways to kind of get around the limitations of the discrete probability distribution by assigning numerical values for certain outcomes. Again, the probability is 1/2 for each. Now, we can find the mean and we can find the standard deviation for a discrete probability distribution. Finding the mean is pretty straightforward. You take the sum total of all of your random outcomes and multiply them by their corresponding probabilities. So in this case that we would have up here, to find the mean, you go 1 times 1/6 plus 2 times 1/6 all the way up to 6 times 1/6. And that would give you your average numerical outcome. Now, if we took all of our possible outcomes that we had, 1 through 6, and let's say we did this 1,000 times, what would our average number be? Well, it stands to reason that our mean would be halfway in between. For every 6 there would be a 1, for every 2 there would be a 5, for every 3 there would be a 4. If we averaged up all of these numbers, we would get 3.5. The standard deviation is calculated by using this formula here, where you have the sum total, and you do the random variables of x squared times p of x, and then subtract the mean squared. Now, I'm not actually going to have you do these formulas out. I'm going to show you how to compute these in StatCrunch in the next video. But before we get there, we also want to look at our range of usual values. And our range of usual values is our mean plus or minus 2 times our standard deviation. And this is going to be fairly universal for all of the probability distributions that we're going to be doing. we're going to have to find the mean first, and then we have to find the standard deviation. Again, we're going to use StatCrunch to make that happen. But calculating the range of usual values is something that you're going to need to do. And remember that our range of usual values between -2 and +2, it just means that if you have a score that's less than 2 standard deviations from the mean or greater than 2 standard deviations of the mean, we say that that value or that outcome is unusual. Here, we say that's not unusual here. Now, again, we don't say the usual outcome, because that specifically means the mean. We just say it's not unusual using a double negative here, and that's going to give us a range of those values.